Can you hear me?
There are categories of technology which rarely leave the data center environment, storage being one of them. Overlooked is one of the core components running in the background of core services, such as banks, hospitals, and half the internet. This storage is able to survive catastrophic hardware failures without losing a single byte, the depth which people build whole careers on. So, this is my version of it, albeit much less grand and much less important. All my hardware, which I'm utilizing in this video, is second-hand, costing less than the next iPhone. What I'm referring to, what I'm alluding to, is Ceph, specifically Rook Ceph. This being technology which runs in most modern infrastructure environments, and as a nice bonus, it's open source, meaning it's free. So during this video, I'm going to take you through me installing it to my own hardware and going through the ups and the downs and the many pitfalls which come with that. So dear viewer, join me as we deep dive beneath this iceberg enterprise storage. So, the plan was simple, which you already know that makes it a red flag, but before we get into that, I would like to have a quick rant. So, each Ceph tutorial on the internet is either boring as shit, therefore you click off it in the first 30 seconds or fall asleep halfway through. What I want to do is learn interesting concepts which I find integral to infrastructure, transfer this technical knowledge in an interesting and engaging way. Keep in mind, I am learning all of this on the fly, so let's actually learn. You need to understand two concepts. So let's start. A container runs a specific application, much like a virtual machine does, but without the bloat. A VM being an entire operating system, just to run one app. A container is like giving Venom Snake in a cardboard box everything he needs to operate. It is portable, drop it anywhere, and it just works. It's light because it's not carrying a whole second operating system around, and it shares the ground which everyone's standing on, that being the host kernel. Now imagine hundreds of these boxes across 6 machines. Something has to decide which runs and which dies and which quietly gets reset. Now that's Kubernetes. K3s for short, being the lightweight version which runs on gear like mine. 3 of these machines are control planes, the managers essentially. They vote. The way they vote is called quorum. This is a majority. They all have to agree before anything comes official. That's much like you and your 8th month situationship. Why it's 3. When one manager dies, the other 2 still outvote the silence. So here's the bit that got me. 4 managers is not better than 3. Both only survive 1 failure. 5 supports 2, so on. So you go odd or you just waste your machine. Losing the majority and the cluster doesn't lie to you. It freezes because a manager that can't confirm the truth would rather shut up than make any sort of decision, which is quite... But without quorum, every manager ends up believing it is in a different world, which is a great way to corrupt everything. Keep that number in your head, number 3. It will come back later and it will not mean the same thing, as I learned the hard way. So, starting off, Ceph just flat out refused to run. When reading the logs, it gave me some hope that it wasn't a complete lost cause. It essentially was my CPU. Ceph was moaning that my CPU didn't have the correct instruction set. For context, my CPU is Xeon, meaning that my CPU should be able to support this. The area was technically lying to me, so I beat into submission, as you do. From previous experience, I remembered that in Proxmox, which is a hypervisor used to host VMs, hands out the machine's default CPU type being KVM64, which is a type of method used to virtualize CPU cores. It's ancient, basically, and it essentially hides half of the CPU's actual features from the VM. Features that the software might generally need/use. On the other hand, the host doesn't emulate anything. This is me changing from KVM64 to host. The host doesn't emulate anything. It just shows the VM's real CPU, all warts and all. And later down the road, one saying change later, it stopped lying to me and we both can move on, which was easy. It shows me the real CPU, and an hour later, my issue was a simple drop down menu. Be like that sometimes, don't it? Now we go into the real meat and potatoes, or just the meat. Doesn't really matter, really, does it? But from a high level, when you save a file to a machine and that machine decides to commit seppuku, just off itself, the file on that machine dies along with it. Ceph, however, refuses to let that happen. It takes a disk across every machine, pulls them together, and writes every piece of data 3 times over across 3 separate machines. Now this is called replication. So any one machine can die and your data is still safe on the 2 other machines. The idea is Kubernetes, high availability. Lose a node and the cluster keeps running, just in a degraded state until it recovers. And yes, it's that magic number 3. But this is not quorum, don't get that mixed up with quorum. Quorum was when the managers are agreeing on the state of the cluster. Gone to shit, or it's alright. This is your actual data itself. 2 different systems, same number. I mix them up so you don't have to, basically. Go on to Rook. If Ceph is the storage system, Ceph is also famously a pain in the ass to run by hand and configure. Normally you would need to know what you're doing, be a system matter expert, and yeah, it's basically just a fucking headache, can't lie. Rook is an operator, essentially. His whole job is to run Ceph inside Kubernetes for you. You write a short YAML file, saying basically what you want to do, and Rook deploys it. Claims the disks, wires it all to Kubernetes, and babysits the whole thing, basically, and ensuring everything stays healthy. It's the reason I could do all this instead of spending a month learning how to write Ceph by hand. So that is what Rook does. So if you're like myself and you previously used something like Longhorn, this is what I run within my production environment. You'll feel familiar. And I'm bringing up this comparison purely because for someone like myself, compare it to something I've done previously, it's just a nice way to finish it off, basically. So both keep your data alive within a pod, even if a whole node dies. The difference basically is just the scope and scale of it all. Longhorn is lean and does Kubernetes block storage brilliantly, while Ceph on the other hand is heavyweight block and file system and object storage all running with a single cluster. Same tech, but this is actual enterprise software. The trade-off is being a genuine pain to run, which you've watched, you masochists, but through the use of Rook, you can see it's not too bad. It's just, if you want to make something custom, it's a bit of a pain. I will show you some quick proof. I write a file into the cluster and then completely destroy the pod holding it. And from running this command, you can see the data was never actually stored within the container itself. It was merely a middleman. It writes an RDB, RADOS block device, and distributes the data across the 3 OSDs, the object storage daemons, on the 3 worker nodes themselves. I know I just threw a lot of buzzwords at you and a lot of like, what the fuck's going on, but all you need to know is that the data lives inside Ceph itself and not the container. So the original plan was to build a 3 copies, and these 3 machines sound bulletproof on paper. I'm just going to prove it's not, basically. So when I kill a node, it survives a failure, but it can't fix itself. It just sits there in purgatory, trying to stem its own bleeding. Why can't you just rebuild the missing copy? I'm glad you asked, little Timmy. Because the rule was never 2 copies on the same machine, and all 3 machines already have one. There's generally nowhere to put the 3rd copy, so it just can't. It just sits there in purgatory and just waits. So the solution was a 4th machine. Now, the real power is there. Killing machine off for real this time. No warning, just witnessing how the cluster reacts, specifically not calling it. Now we're shooting the node in the head, essentially. What is a cordon? I'm glad you asked again, little Timmy. A cordon essentially is forming Kubernetes, not to schedule any new pods onto this node. Think of it as a planned maintenance mode. And this exact politeness is what killed my first attempt. It was waiting for the node to come back online, giving it the no out flag as it refused to heal itself. And removing the flag didn't help either, because the operator just kept reapplying it as long as the node stayed cordoned. The politeness was just self-reinstating. Basically, I'm too fucking nice to people. So for my second attempt, I was a lot more abrupt. I just plain just shot the node without any warning. I just turned it off. Late in the cluster, I think there was a genuine node failure, that system hardware, whatever. The 3rd node, my redundancy was gone. And then green. Ceph rebuilt itself using the spare machine into a 3rd copy, all by itself. The VM was still off, the original one which I turned off, did nothing. I never felt more useless or more proud in my entire life. Now I'm going on to this. Just for the shits and the giggles, it takes about 10 minutes for rebuilding even to start. To be fair, that's smart in hindsight. It doesn't start panic rebuilding over a machine that may just be rebooting. I did not know this at the time, so I just spent those 10 minutes, sat there, and then after like 6 minutes I was like, shit, what the fuck's going on? And I thought I somehow broke it. But once the machine was more calm than me, so as a conclusion and as a summary of what I've kind of said, 3 machines basically get your data to survive death. 4 gets your data to repair itself without any external factors to help it along. That is the difference between it tolerant a failure and actually recovering from one. And this is basically what every tutorial I feel kind of skims over. It says 3 nodes, which is high availability. They are half right, but it obviously does scale. And look, if you're trying to get into this field, building this and being able to explain why the 4th node matters, this puts you miles ahead of someone who just understood. If someone just a certificate and kind of has nothing to show, like hands-on, I'm literally using this exact cluster as evidence for my engineering accreditation. O-Labbing, I feel, is kind of a bit of a cheat code, for especially in DevOps and extension software engineering. Do the thing, document the thing, put the thing in front of a human, fingers crossed it works. Generally, if you've got to this far, thank you for watching. As you know, I'm quite new to this myself, learning this on the fly, and thought it'd be funny to probably humiliate myself and put it in public. Well, I show every trap that got me, the line CPU, the politeness of the bug, all of it, take them. Already paid for them 4 days of my life. And yeah, if you survive that, you know what the buttons do. And if you rather keep your favourite niche channel from the masses, honestly fair. I kind of like, when they get too big, they kind of just sell out.